All right, welcome everybody to this afternoon keynote session. So I'm Philippe Goulet-Coulombe, one of the local organizers, professor here at UQAM. And I have the privilege to introduce to you the keynote, Domenico Giannone, who is officially, you have a fancy long title, Bloomberg Distinguished Professor of Economics and Statistics at Johns Hopkins University. So his CV is long, and in fact it's you worked at a lot of fine places, among them the IMF, Amazon, the Federal Reserve Bank of New York, Université Libre de Bruxelles, the ECB, and then I thought it's actually easier to find a good institution we have not worked at. But anyway, so nice stuff. So of course, beyond that, Domenico is a true innovator in the field of macro forecasting. I mean, when you think about Bayesian VERs, large data, factor models, nowcasting, and of course, more recently, all this risk assessment, tail risk, you name it. So I think I'll stop it there because I guess he has some new innovations that he wants to share with us. So I think I'm going to invite you right now to the stage. Let's welcome Domenico, everybody.
Thank you very much, Philip.
Of course.
I think I'm gonna stay with the.
You don't need that, yeah.
So thank you very much, and it's a great pleasure to be back at the International Symposium of Forecasting. I realized how much I missed it. The last time I was in 34th edition. It was in Rotterdam, and before that I was in Boston and in New York. And these days I realize how much I've been missing it. So thanks a lot for the invitation, for your nice words, and thank you everybody for your interest. So thanks a lot for saying I'm innovator. I really, in the end, like my research is all about forecasting, so that's why it's such an honor to be here. So this is, the paper I'm presenting is about forecasting risk. And it's sort of, it's an attempt to try and, at least for me, try to understand how we forecast risk and try to put some order in my mind about how we do that. And it's coming from a lot of experience in places I've been. So both in policy, but also in the industry, both the financial industry and in the tech industry. And so basically, the way we look at risks is, we do it in two ways. We look at, let's say, predictive densities, looking at, we put the probabilities about all possible numerical events, case of inflation being 2%, a probability of being 3 or negative, and so on. This is one way of doing it, which is mainly statistical. But there is also another way we assess risks. And it's done through scenarios, through stories. So we say, oh, my forecast for inflation is 2%. However, if the invasion of Ukraine goes on longer, inflation might be higher and maybe GDP lower. Or if instead the invasion stops now, maybe inflation is going to be more stable. And, this is something we do we do very often with doing these narratives. Now, something I realize is that these two approaches typically don't talk to each other. And so this talk here is an attempt to try and understand how can we put these two things together. The motivation came for writing the paper from working at the IMF. So at the IMF, there are two main publications. One is the wheel, which is done in the research department. And there they do forecast for all economies and also for the aggregate economy. They do point forecast. They put confidence bands around it, typically time invariant bands. But also then they put some scenarios. And they started doing scenarios 10 years ago. And now, in this high uncertainty situation, they are doing scenarios more and more. Actually, not only the IMF, but also many, many institutions are reporting scenarios. Then there is another department at the IMF that is more about capital market and monetary policy. They also do forecasts for the world economy. And they look at the financial market and the interaction between financial markets and the macroeconomy. So what they produce is an assessment of risks to GDP, basically to growth. And the way they do it is by looking at fund charts, putting probabilities to different numbers, to different, the probability of GDP being below 0 or being above 4 and so on. They produce a full predictive density. It's something called growth at risk. Interestingly, these two group of people doing this analysis, of course, they talk to each other a lot, but it's very difficult coordination. Sometimes, you might have growth at risk indicating downside risk being prominent. And then when you see scenarios, typically scenarios, they report different stories. But the story that they tend to report, usually there is no quantitative assessment. So the only way to assess whether in these scenarios the downside or the upside is prominent, you have to count the negative scenarios and the positive scenarios. Okay? So we started working on this together with a co-author from the International Monetary Funds, Tobias Adrian, a co-author from the Fed, the Fed board, Matteo Luciani, and then Mike West, which is also an academic statistician at Duke. Since Matteo and Tobias are in institutions, the usual disclaimers apply. These are our own opinions, not necessarily those of their institutions. So what is going to be the presentation about? I'm going to focus on monetary policy. And in particular, I'm going to focus on the way risk and uncertainty is assessed in the Fed. Okay, so for the monetary policy decisions. However, most of the discussion I'm having here can be applied to general situations. I imagine for those of you who work in the industry, I'm pretty sure you have been facing similar challenges. So you can think about translating this in your kind of problems. I'll try to do it somehow, but in case we can have discussions in the question and answer later. Okay, so this is the main motivating picture for this paper. So this is an extract from the Thiel book. So the Thiel book is the briefing that economists at the Board of Governors of the Federal Reserve System, the briefing that they prepare for the FOMC. The FOMC is the Federal Open Market Committee. It's the body that makes monetary policy decisions. So before they meet, they receive this assessment from the economist, and there is a long discussion about everything about the economy, the macro, and the financial, and then there is a lot of discussion there. There are several chapters, and one important chapter is this one, which is called Risks and Uncertainty. Okay, is the chapter with the blue, color. Okay, and the way they do it, these risks and uncertainty, these are the two charts. Here is done via scenarios. Okay, and this is in the Thiel book since the mid-90s. So there is a long tradition, more than 30 years, systematically. Before it was there from time to time, but in the last 30 years, every time they meet, they produce these kind of scenarios. They do it for GDP, unemployment, and inflation, and the policy rate, the federal funds rate. So what they report, this is in black, is the history of GDP growth. This is year-over-year growth. And then there is a forecast. So the black is the point forecast. The shades around it is uncertainty, is uncertainty around the GDP forecast based on historical error. So they computed the variance in the past, and this is the way they computed these bets. Actually, they've become more sophisticated recently. They look at the quantiles of the historical forecast error, so you see some asymmetry. Okay? So this is called the baseline forecast. Okay? And then they also report several other colorful lines. Okay? These are scenarios. Okay? And this is the Thiel book done in December 2018. Okay? I'm sorry, I'm going to use things from the past because this is not publicly available. It's released only with a 5-year window. And we are going to get the Thiel book covering 2020 and 2021. We are going to get it in December. It's going to be extremely interesting to look at that. Okay? So in 2018, they were looking at different kind of scenarios. You see, like there is this yellow one is a recession. So basically, it's GDP growth much below the baseline. And then you also have some additional, less severe scenarios in the downside. And there is only one in the upside. Okay? So this is some analysis that they report. And they do it also for the other variables. Then there is this other page. If you scroll the book in the same section, there is this other page which they called time-varying uncertainty. And what this is this chart. Let's focus on GDP here. What they report is the forecast errors of GDP growth from the model. But now, instead of looking at the unconditional quantiles, they look at the conditional quantiles, so try to predict the quantiles of the forecast error using additional variables. And typically, this kind of variable are financial conditions. And you see what happens is that there is a substantial variation in these quantiles of the errors. And in particular, you see that during a recession, they tend to be wider on the downside. Okay? So basically what happens is that when financial conditions get tight, you have an increase in downside risk. Now, if you go and look, by the way, all the transcripts are available on the Fed website since, I think since it was established. So there is a long record. So you can go and read these books. And the interesting thing is that these two sections don't talk to each other. So there is no discussion at all between these two sections. Okay? And so what we are trying to do is to try to make them talk. So the presentation is about how central banks analyze macroeconomic risk. And actually, when trying to solve this problem for the IMF and for the Fed, and also I tried to use it also for when I was working at Amazon, I also went through what the people are doing. You know, I'm specialized in monetary policy, so I went and looked at what is the practice in central banks, and actually it was an extremely interesting journey. I will not be able to discuss all this during this presentation, but you can look at the paper. So we are trying to reconstruct what the central banks do. And so I'm going to also discuss the disagreement on how this should be done. Actually, you will see later on that there is an important disagreement on how to analyze risk, and this is emerged recently following the review of Bernanke of the Bank of England process. So our proposal, so there is going to be a positive part in this paper, is a proposal to merge these two things, and this is what we call a scenario synthesis. Okay? So basically, we are going to compress all those scenarios to make them compatible with this statistical assessment of risk. Okay? So put scenarios together to get close to the fun charts. And I say, like, the case study is going to be macroeconomic risk at the Federal Reserve Board. I'm going to work with the Teal book, and we are just going to use publicly available information, so only things that are printed. So, but this will make some limitation in the analysis that we can do, but we can discuss about this later. Okay, so as I said, there are these two approaches. One is scenarios, and the other is looking at predictive distribution. Scenarios are typically done with economic models that are used to generate the baseline and also to produce some scenarios. Sometimes the models that are used for the scenarios can be different from the baseline. But in general, these kind of models are simple models. Typically, these are models that don't feature nonlinearities. So risks in this model is a time invariant. They are very simple. At the Fed, it's called the FIRBUS. It's a large-scale model, linear model, basically. And typically, the scenarios are done either with the same model or with alternative model, but still very simple. Okay. The alternative, the other way, is that looking at the predictive distributions. So these instead are generated with the statistical models or with judgment. And since they are generated with statistical models that are flexible, they can capture some nonlinearities, as the one we saw before, that uncertainty changes over time, and it also allows for a linkage with the financial conditions. And this predicted distribution at the Fed are quite new. So they have been introduced in the Teal book only since 2017. So it's only in the last 10 years that they are looking at that. Before they were looking at the time invariant risk. Okay, so these are the two charts I'm going to focus here. Throughout the presentation, I'm going to focus only on GDP growth. But all the analysis can be generalized by looking at also jointly across variables. If I have time, I will give you an idea of that. So let's look at the scenarios. Let's zoom a little bit more into it. So this is the chart that we saw before. So here, every color is a different scenario. Stronger financial-based recession, or stronger supply side, supply constraint, greater interest rate sensitivity. So this was in a hiking moment. So they were worried that the economy might react too much to the increase in rates. So that was a negative scenario. And then lower oil price, foreign slowdown, and so on. And then an interesting thing, it's a very interesting information there. There is a lot of narrative about those scenarios. So there is a narrative that explains to you how these different scenarios unfold if they happen. So and that's the beauty of the scenarios. So here I'm highlighting a scenario that is a financial-based recession. So this scenario is basically looking at the spillover from the financial markets. Now, the baseline model of the Fed, the FIRBUS, doesn't have a financial sector. So what they do, they look at the satellite model. This is a DSG by Gertler and Karadi, where they feature financial frictions, and then they use it to do these scenarios. So they assume that there is a correction in asset valuation beginning in a quarter, and then they discuss how it unfolds and so on. So what I want to stress here is the fact that there is an interesting narrative about those scenarios, and that's something that the policymakers, people that make decisions, really like. And my experience in the industry is that also the CEO of a company or people that are the senior management also like that because there is a narrative. Okay, so we tend to do scenarios, maybe not as formal as this, but in the industry there is a lot of this kind of analysis. Okay, so here instead let's zoom on the predictive distribution because the chart I showed you before was pretty small. So this is the chart they produce for GDP growth. This is historical variations of the predictive density centered at 0. So think about this as predictive density once you remove the baseline forecast. And then they report the last, this is 1 year ahead. So they were predicting this kind of density for the future. Okay, so you can see already from the history that this was a situation in which pretty neutral. Okay, so there was no major upside risk or no major downside risk. Okay, and they also report the selected quantiles. Okay, so this is on the forecast errors. So you see that it's pretty much balanced around 0, and it's symmetric. Actually, this kind of analysis is getting a lot of traction. So this is something the New York Fed is publishing it regularly in real time every month on the website. They call it Outlook at Risk. So you find a similar chart. Actually, this is something when I was working at the New York Fed, there was also a survey in the research floor across economists. They asked us to feel basically like putting probabilities in different bins for GDP, sort of survey of professional forecasters internal. This is another interesting document that is prepared at the New York Fed. So the New York Fed president is the vice chair at the FOMC. So for this reason, it's also the New York Fed is also producing a backup in case there are problems to ensure continuity. So they produce this book that is called the Black Book. Okay, so there you can find this kind of analysis. And this is, like the way they reported the result of this survey. So these are predictive densities for the future of GDP. Okay, and it's also compared with historical bands based on the historical root mean square error, and you can see that actually here uncertainty, as assessed by economists in 2018, was much smaller than the average uncertainty. Of course, doing predictive densities is something that forecasters have been doing from a very long time. So the Survey of Professional Forecasts, they do it since 1968. Okay, and here, this is the blue density, is the SPF. Okay, while the red is what the Federal Reserve Bank of New York produced in 2007, just 1 year before the great financial crisis. Okay, so this was based on judgment and so on. But I'm going to look at this. And this is, of course, the river of blood. That's the way they call the economist at the Bank of England, because it goes a lot of work goes to do that. So this is since 1995-96, Bank of England, in its inflation report, they are producing these quantiles. They call it fun charts. Okay, different quantiles for inflation. Okay. Now, so there is a long tradition on this predictive density. However, recently there has been an assessment of Bernanke for the Bank of England, and basically what he said, we have to eliminate these fun charts. Okay, so he said we have to eliminate them because it's difficult to understand what these predictive distributions are, and because of this, we have to move more and more to the use of scenarios. Okay, but it was a very strong assessment of remove it. And actually, he also made the mock-up of what should be like a briefing of economy for economists, also for the external communication. He said, you have to produce a baseline forecast, density forecast, and then alternative scenarios with some bands around. This is something that he presented last year. Okay, so but let's go and think about the scenarios. If we eliminate these fun charts, of course, scenarios by themselves have important limitations. They are amazing because there is a narrative. However, they are just narrative. There is no formal metrics on how, for example, what is the weight we should put to different scenarios. And then, scenarios, think about the scenarios I showed before. You don't report hundreds of scenarios, typically a handful of scenarios. Then the question is, are those scenarios really covering the relevant risk, or something important is left out? Okay? So our proposal is to mix together scenarios and the predictive distribution. So we combine scenarios in order to be as close as possible to predictive distribution, so that we can get the communicative strength of scenarios and the statistical rigor of predictive models. Okay, so let me try to formalize what we do. So think about what is a baseline forecast. Is a predictor, I call it the P of P0. 0 stands for baseline. For the outcome, Y is possible values of GDP, and this is conditional distribution for Y, conditional on some assumptions, which I call A0, and some model M0. Okay? Baseline assumptions, and M0 is typically at the Fed, the FERBUS. Okay. So alternative scenarios are very similar to this. So they are just conditional distributions now, but conditional on alternative assumptions and possibly alternative models. Okay? So here they go for, there are capital J scenarios. And then we have a reference distribution, which is a predictive distribution, just statistical, okay? Which I call P of Y. So our proposal is the following, is to take those scenarios together with the baseline and do a mixture of them and get F of Y conditional on alpha, where alpha are the weights we put on those mixture. Okay, so it's a combination of baseline, forecast, and alternative scenarios. And then the question is how to choose alpha. Actually, this has been for me a very difficult problem and I've been trying to solve it for a long time. And, it seems, if you look at the problem like this, it's very simple. It's forecast combination, right? So you can say, oh, I'm looking for the alpha such that I get the best forecast. What does it mean? Best forecast is the one that scores best relative to what I observe. Okay? Unfortunately, this cannot be done. And the reason why it cannot be done is because the scenarios typically change from one round to another. And actually, they change from one round to another without telling you why they remove one scenario, so why they put another scenario, and so on. So it's not very well organized. So this is, if we had always the same scenarios, that would be a very simple problem. Okay, so what we do here instead, we are going to use basically as evidence, instead of the data, we are going to use as evidence, think about the data generated by P of Y, by the reference. So think about to generate the data from P of Y and apply to those data optimal combination. That's basically what we do. And, once you get this weight, you can understand which scenarios are more important. And also, once you combine, you can look at the difference between the synthesis and your statistical assessment. And then by looking at where probability mass is missing, you can understand where some scenarios are missing and what you should do. For example, it can also help crafting scenarios, which is something I don't do here. I'm just going to use the scenarios prepared by the Fed, but you can use this tool also interactively. Okay, so case study. So how much time I have? 10 minutes. Perfect. So case study, I'm going to look at December 2018. This is a very simple situation in which the economy basically was not under stress. These were these scenarios and the baseline. This here is the reference, the statistical distribution. So what we are going to, these are we are just looking at the forecast 1 year ahead. And then what we do, we combine these two things in what we call it the synthesis. And once you do that, you get some weights. So in this case, the baseline gets almost 90% of the weight. And then the stronger supply side, so the upside gets additional weight. Okay? But the baseline, according to our synthesis, provides a very good discussion, good representation of the risks ahead. So these two analyses seem pretty much compatible. Okay? And also the other thing is that this table is telling you that you shouldn't be too scared about the yellow line. Okay? So one of the reasons why I started doing this is when I was working in the industry, I presented it was during COVID. And there was so much uncertainty that the only way to communicate what happens is via scenarios. And I had some not nice scenarios. And I remember a senior leader telling you, why are you trying to scare me, right? Should I worry about that? Why are you telling me this? But at the time I didn't know how to answer formally. So by putting weights, you can say, oh, don't be too scared. I'm putting that on the table just to understand the mechanism or something low probability, but don't be too scared. Okay? Doesn't move. This is a more interesting situation. This is a situation in December 2007. Okay, so be with me. We are 1 year before the collapse of Lehman Brothers. Okay, so think about economists sitting at the Fed board trying to understand what was ahead. Okay. It was the Queen of England that says, why you didn't understand that? So there was why economists didn't understand that was coming. Actually, if you look at this chart, economists at the board were pretty aware of what was happening, what could have happened. So they had, a baseline scenario, which was pretty okay, a little bit on the downside. So by the way, December 2007 was the beginning of a recession, which was dated much later, but then the recession started. So they had some probability to negative values of GDP in the next year, but also they had some scenarios that were negative. And look at the kind of name they had in these downside scenarios. Credit crunch, greater housing correction. So in a sense, the economists, they had good foresight at the time. Okay. Now let's think about. Unfortunately, you cannot have probabilities here, right? At the time at the Fed, at the board, they didn't have predictive densities. However, at the New York Fed, they did. Okay, so the New York Fed had this predictive density that was this red bars. Okay, and here for comparison, this is a plot I got from there. For comparison, I have the blue, which was the professional forecasters. Okay, Main Street versus the bank. And look at here, the New York Fed realized that there was a probability, more than 20% probability of negative growth year over year. Actually, this is annual for GDP. Okay, so they realized that there was some probability of things getting wrong. However, Main Street, people didn't realize that. They were pretty sure the economy was strong, would stay at between 2 and 3%, and so on. Okay, so let's do the synthesis. Think about how I want to put weights to those scenarios in order to match these predictive distributions. And if I match the New York Fed predictions, this is what I get. Some weights. Actually, the baseline is not a model distribution, right? So the probability is spread across several scenarios. And, the credit crunch gets 25% probability. Okay? There is also some probability for the upside, but, this, you see that there is a lot of uncertainty, and the baseline is not so useful. There is a lot of uncertainty. If instead of the New York Fed forecast, we were matching the SPF instead, you would say, oh, there is no probability of this credit crunch and so on. Okay? So importantly, the New York Fed is close to Wall Street. So that's one of the reasons why they were able to get early signals of these problems. Okay? And the president of the New York Fed went to the treasurer. He wrote the book about the stress testing, so there was a lot of discussion there. Okay, some more math, but math is extremely simple. Basically what we do, we combine the baseline and the scenarios to get a mixture, and we want the mixture to be as close as possible to this reference distribution. And the way we match it is by using the expected misclassification rate. So think about it similar to Kullback-Leibler distance. Actually, it gets very similar, but it has a much better interpretation. So to understand what it is, so suppose that you observe y, and the y is generated from a P of y from the reference. So this expected misclassification rate tells you what is the probability of mistaking the distribution from which it has been drawn. So it has been drawn from P. What is the probability that you might attribute to the mixture? Okay? If this probability is 50%, it means that the two distributions are perfectly identical. Okay? So this is a nice property because you can put the scaling of this as a clear interpretation. The Kullback-Leibler distance is difficult to interpret. But this is basically what we do. Okay, so not important. We have to put some prior. It's a maximization in the simplex, very simple and powerful also because maximizing the simplex also allows for, you can put as many scenarios as you want because it's implicit regularization. Okay, I think I just graphically show what happens. So we have this reference. So as I said, like the reference, we only have selected quantile, so we are just using data from the Fed, so we have to fit the distribution. But if you have all the draws, you don't need to do that. So, but you get this kind of distribution in 2018. Then you have some scenarios. This is the baseline with the quantiles. This is the difference between the reference and the baseline in 2018. And then you have these scenarios. So we don't have, so these models are linear. So we assume that the scenarios are just a shift from each other. So we mix all those things to get the synthesis. And then you get the difference between the reference and the synthesis. And you can see that pretty much by comparing the two, you can understand how much uncertainty if there is a part of the probability of the support that you are not covering well. So here the synthesis is able to cover pretty much the reference. So the scenarios we have are able, that they had at the time, were able to cover the most important risks. If you go to 2007 instead, so this is the baseline, the green, and this is the reference. You see, it's much different from the baseline, okay? And these are the scenarios that were done by the Fed. And once you mix them, you get this blue synthesis, okay? The synthesis is better than the baseline, but you see there is a lot of uncertainty that is not covered, okay? And the reason why, you can see very easily why it's... So the Fed was pretty good in understanding that there was some downside risk, but the scenarios in case of downside was pretty mild. Okay, so if they had this kind of tools, they would understand that maybe under a credit crunch, things might have been worse, or they could have had more downside. Okay, so you can also do multivariate. Just want to show the cute charts that you can get when you go multivariate. This is GDP and inflation. And, okay. This is the conclusion. I don't think I need to repeat. So just by combining scenarios and to match this predictive distribution, you can get weights on the scenarios, which can be useful also to understand set incompleteness. Thank you very much for your attention.
Okay, thanks so much. Do we have, well, I presume we have some questions. Anybody want to go to that? I see somebody in the back, so there's a microphone there, if you don't mind.
Thank you, Domenico. Great presentation. I enjoyed it a lot. You mentioned narratives in your presentation of these documents. Have you thought about any way in which you can incorporate those narratives? Do you think there is an use of that?
Oh, yeah, that's absolutely. There is, I think those narratives are extremely important for us to understand the risks. And, you know, by looking at the narrative in the past, we might be able to extrapolate risks in the future. And large language models could be extremely useful in this. There is only one paper that has been working on this. It's a paper by an employee of, a retired employee from the New York Fed, published on the International Journal of Forecasting, by the way. And it's about, they are using the text, the discussion in this risks and uncertainty in order to predict the risk on GDP. The interesting thing that happened is that they use very basic language models. It was before ChatGPT and the large language model revolution. But the interesting thing is that this narrative is not useful for forecasting the point. It doesn't improve the mean square error, but it's extremely powerful in improving the downside risk. So, yeah, so one of the projects I'm trying to work is using reports from different institutions in order to understand the risks ahead using large language models. Yeah, that's an interesting way of combining. Yeah.
Question? Yeah.
Thank you. A wonderful presentation. Are the professional forecasters almost always more optimistic than the people at the Fed and the IMF?
I haven't done a full assessment of this. My understanding, you know, this is coming before I started getting to here. I was evaluating professional forecasters in Europe. My understanding is that they usually under-evaluate uncertainty. Yeah. So that's pretty clear. They under-evaluate. That was in Europe, it's not here. But I would expect that, I think what is happening here, and maybe there is also information in professional forecast to be exploited, what the New York Fed knew at the time, it was information from the financial market. So at the end of 2007, financial conditions were already getting tighter. Okay? So the VIX was already very high. The spread started going up. So maybe the professional forecasters that were in the financial market understood it probably better. But I must say, it's possible that after the great financial crisis, people have incorporated those things. Mm-hmm. And, you know, the Fed, for example, since in the last 10 years, they are looking indeed at predictive densities using financial conditions. Okay? So probably, like nowadays, hopefully, they will be able to get more precise forecast.
Thank you.
Yeah. Have you looked at a paper by David Draper? I read this literature many years ago. It was a complete Bayesian treatment. So he talks a lot about the scenario distributions, and he gives a beautiful example of oil price forecasting, and just before the whole glut happened. But in the scenario, kind of, it captured part of the uncertainty that was coming, okay? And it's a complete Bayesian solution where it integrates out all this and gets a posterior distribution of forecast, okay? Have you seen, it's a classic paper, I know. Okay?
Absolutely, thank you a lot, and I will be very interested in the reference. Something I want to stress, I didn't stress here, actually one of the co-authors is Mike West.
I observed this.
So Mike is a Bayesian statistician, and The reason why we teamed up is because Mike showed that scenario synthesis, so when you do when you do a mixture of densities, they have a formal Bayesian interpretation. So in this case, you can think about the density that the weights, you can think about the updates based on the evidence, where evidence is, so you start with the prior that is uniform across the scenarios, and then the evidence here is this growth at risk, is this predictive distribution. So you update on the basis of this predictive distribution. So it has a formal Bayesian analysis, but absolutely, I'd be very interested to see that reference, I don't know. Thank you, Kaya.
Great talk. Thank you.
Thank you for the presentation, Domenico. I have one question concerning the uncertainty of the scenarios. It looked as if the uncertainty of the scenarios is always the same, or was I mistaken? Because I would guess that conditioning on different paths, on different evaluations in the future should give you different degrees of uncertainty. You know, for example, conditioning on, let's say, an oil price path should take out a lot of uncertainty, right?
Absolutely. So that's, and I think this is something extremely important, and we discuss in the paper. So the way I'm thinking about this scenario analysis is a way, as a policymaker or forecaster, we deal with deep uncertainty. Where by deep uncertainty means we don't know what is the model, right? We don't know what's happening. So we are sort of in a Pluto cave, right? So we see some shades and we are trying to understand what happens. So these models are sort of, the baseline model is the representation that we think is the closest, the model in a sense. And then all these scenarios are perturbations around this model. Now, usually, the perturbations are done in a linear way, right? But then I think it's very important, and now we understand that when we do scenarios, they have impact not only on the point, on the mean, they also have impact on the uncertainty, right? So if, AI, okay? So we have AI. So this has implication, not only probably productivity is going to go up, but also the uncertainty is going to go up, okay? So now these scenarios that we have, they just give us a point forecast. But some of the model they have, for example, Gertler and Caradi, if they keep it nonlinear, they can have the full nonlinear distribution, and you can start thinking about different scenarios are not only shift, but also different shapes and so on. But that's absolutely important. So when you do these explorations, you typically do it with smaller models. And with smaller model, you can afford some more nonlinearities. For example, you can do a DSG with the Markov switching or approximate at second order. And I think this is super important these days.
Thank you.
Well, I think we're going to have to keep the other questions for the coffee break. So let's thank Domenico one last time.
Thank you very much for your interest and for interesting questions.